Hello everyone, this is a video lecture for Calculus 3, section 12.4, cross product. So I'm going to first give you a formula, and honestly, I'm going to tell you that I do not follow this formula. I do a different method. But if you had two vectors, A, B, C, cross, that's a times sign, but it's obviously just a cross instead of a dot or something. So cross D, E, F, the formula would be as a equals a vector. You have to recall that this is a vector compared to a scalar, which is just a single number. B times F minus E times C, C times D minus A times F, and then finally A times E minus B times D. And now you can kind of zoom out and see why I am not going to use that, because I can't remember this. But it is something that you could always reference if you really had to. Let me show you the way I do it every time and how I'll be doing it through the rest of the section and other sections to come. So I say but, here's a new one. There's a concept that we have to know beforehand, is the right-hand rule. Is that we have I goes to J, goes to K, and then back here. Right-hand rule. I'm not going to show you the right-hand rule because you can't see me. But essentially, you take your right hand and you point your fingers. You have to keep it flat palm, fingers extended, and you point in the direction of the first vector. You curl your fingers into the direction of the second vector, and your thumb points up at towards where the cross product would end up. Now, this kind of gets a little weird whenever you have to turn your hand upside down in order to curl it correctly and all that kind of stuff, but that is the right-hand rule. It's always counterclockwise also, just like how we've learned angles go counterclockwise. The same thing here, okay? So let's now I'm going to give you, with that understanding, a better formula. I'd almost rather call it an algorithm, but I mean it's still formulaic. So we got ABC cross DEF, and then this is what it's equal to. First off, 0 plus A times E times K component plus A times F times negative J component plus, I'll explain a lot more here in just a second, B times D times a negative K component plus 0 plus B, a little bit better there, B times F times my positive I component plus, almost there, C times D times a positive J component plus C, I did that again, C times E times a negative I component, there we go, and then plus 0. What this is actually, it's starting to kind of format a kind of like a matrix in a way. Now it's not really a matrix, but the idea is that I'm using kind of that style, and you could use matrices to do it with determinants and stuff. But there's 3 by 3 elements that we're really focusing on. Essentially, and I'm going to use a different color here, is that I'm basically foiling them. You can see that A is going to be times all these different components. A times D, A times E, A times F. The thing is that whenever you're multiplying these two terms here together, A times D, they're both X components, and so therefore it's going to be a 0. There's a big list where this IJK stuff kind of goes together, but one of them in particular is I cross I is 0 vector. Basically, it results in a 0. In fact, I don't know if it's a 0 vector or not, but it's 0. So let's just say it's a 0 for sure. Vector, not vector, I don't really know. And then we do the same thing with our B. So B, B, and B. And then finally we do it again with our C. 1, 2, and 3. So then you can see we got the 3 different rows and 1, 2, 3 columns, again, for each element in the bottom. So that's the more algorithmic way. If you're wanting to do the style, you must remember the components, though. And then you could do this manually. I times I is 0. I times j is a k. And then I times a negative, or times k is a negative j. And I say times, I mean cross, of course. So like here, I cross j is a k. Here's another one. I cross k is a negative j. Notice why it's negative? Because it's going backwards. So there's a lot of that going on here. You can also get the whole big formula set up. That's fine too. But what I like to do is I like to keep this handy. 0, positive k, negative j, negative k, 0, positive I. If I can do a little dot there. Come on. There you go. Positive j, negative I, and 0. This kind of like, it's not a matrix, but it's kind of like it. It helps me remember what letters go wherever. And so you can utilize this here, and you just basically multiply a number in front of each one of them. So different strategies for different kinds of people. You can do it manually every time. This is kind of like a FOIL. There's other formulas with determinants, but essentially you're going to be doing this a lot. So find a way that you like and stick to it. So let me start doing a couple with actual numbers now. So the first one is 12.4.001. And so they say my A vector is 4, 5, 0, and my B vector is 1, 0, 7. And they want to say, what is A cross B? And in these problems, they have other things that they're wanting, but this is truly the majority of that question. Like, what are we really needing? We need the cross product. So I'm going to rewrite it so that they're on top of one another. That's just what I do. I like to do this style for me. And then I just simply say 4 times 1, 4 times 0, 4 times 7. 5 times 1, 5 times 0, 5 times 7. And then 0 times everything, eventually be a 0. But you have got to remember, 0 always starts it. 4 times 0 is going to be a 0, k. And then 4 times 7, and that's going to be a negative j component right there. Okay. 5 times 1 is going to be a 5, of course. This is the negative k component. Always a 0 in the middle. And then 5 times 7. And then this component here was a positive I component. Keep cruising. 0 times anything is 0, 0, and this is always a 0 right there. So I want to know what all my i's are. Obviously I have i's right there. 5 times 7 is 35. My j components right here, these guys, that's going to be a negative in the end, negative 28. And then we got our k's, again, that's going to be a negative 5. So there's your cross product. Pretty easy. They also want in this problem A cross B, and then dot A, and then also A cross B dot B. I'm going to tell you the answer is always a 0, and that's a 0 scalar because, again, the dot product results in a scalar while this cross product is now going to be a vector. Okay, that's why we got a vector answer right here. So those are scalar answers because you had a dot product in the end. Now, what does it mean to have that 0 there? It just means you got your cross product is orthogonal to the other vectors, therefore the angle between them is 90, etc. Okay. Let's do another one. So I wanted to do a lot of practice here, maybe almost a bit too much. But some of these problems, I just found like, oh man, it just has the same kind of numbers. Look, 5, 5, 5, right? Obviously, that's a -5 at the end. But so it might look a little confusing as I go through this. Um, I'm just kind of going through homework questions, you know. Okay, so this is how I set it up. And then, as you know, if you say 5 times 5 anywhere, what's your number going to be is 25. So we're just making sure that we get the correct signs and the correct components. So always a 0. 5 times 5 here is going to be a -25, but that's a k component. And then 5 times 5 is a +25, but that's a negative j component. So ultimately, that'll be a -25. 5 times 5 is 25, of course. Over here is a negative k component. Always a 0. 5 times 5 right here, it's going to be a 25, and that's a positive I component. -25 way down here. See right here, -25. But that is a positive j component. And then we have two negatives. We'll make a positive 25. That's a negative I component, though, and then a 0. So kind of combining things. I have my I components. Let me use different colors. I have my I components here. Notice that we got a negative and a positive, and they're going to cancel. It's not just the I components canceling. I'm saying that's a -25 in the end, and that's a positive 25, and they're going to cancel. So you don't need that. So start setting up. That would be a 0 for sure. The next one, my J's, this guy and this guy. Notice a negative and a negative combined to make a -50 J. Notice I'm just putting it in the J component slot. And then finally my K's, negative, negative. So they're going to combine again to make a -50 in the end. So there's your answer for that cross product. They're going to also ask for the same thing above, A cross B dot A and all that kind of stuff. And it's just 0. There's really no change for those questions. It'll always be 0. So that's handy. Again, it's only doing that to prove that the cross product is orthogonal and stuff like that. Okay. So moving on. Another one, 12.4.006. Again, I wanted to do a variety, and all the questions were really good, which means that I did a whole lot of them. So this one here, I got T's involved, so that's really good. I think I just scribbled that wrong there. Okay, so putting on top of one another, cross. Again, this is just how I do it. There's a lot of different ways. So you always start with a 0. T times t squared is t cubed, k. T times 1 is going to be a t, but that's a negative j component, so negative t j component. I got 6t, but now that's a negative k component. Always a 0. 6 times 1 is 6, but that's a positive I component. T squared divided by t is just going to be a regular t, but remember that that's a positive j component, so we're good there. Same thing here, we'll get a t, but because it's a negative I component, let's not do that parentheses there, it'll be a negative in the end, and then a 0. Putting all this stuff together, my i's are going to be 6 minus t. My j's, actually they cancel. That's fun. And then we have this t cubed, and then we got this other thing here. Actually, hold on. I think I messed up right here. That's actually a square, isn't it? Right here? Wouldn't that be a t squared right there? Okay. And that's why I do some of this math. I do all of it, actually, beforehand, so I can double check myself and, oh yeah, I got it right. So there we go. So not too bad there. Cool. I guess we can keep going. Next question. Again, I skipped a couple. Not many, but a couple. And then I came to this one and I said, oh, that's an interesting one. Oops. It's a cross. So I cross J cross, cross K. I keep messing that up. And they say, what is that? It's kind of weird because I cross J, this guy right here, is a K, and then you're saying K cross K, that you're not going anywhere, so the answer is 0. I think it is a 0 vector. Huh, maybe I was right about that up there earlier. So 0 vector is actually the answer because how they have it, at least how I saw it, was a bold 0. Now, you could actually go and get bold from the little box on the side, like that little pop-out box with all the little things, and you click on one and it shows more stuff on WebAssign, and it'll be bold. You can do that. But I guess I would also say perhaps regular 0 will also work. I would try it first, because going and clicking that 0 every time would be kind of annoying. So just try to see if the regular 0 works. Hit submit. If it does, cool. If it doesn't, well, then go and find the bold, and then you can do it. I'm going to write bold right here. Okay, cool. Let's do another one. 124010. So I have K component, though you couldn't see that from my wonderful handwriting, cross I minus 6J. Now, if you're thinking that perhaps there's some kind of thing going on here, like maybe there's a formula like up here, well, not really. What I'm going to do is I'm just going to do it the way it looks. What does K component look like in vector form? 0, 0, 1. Cross. You see these guys? That's a 1 right there. 1, negative 6, 0. I'll probably get an answer somehow, so let's try it. Always a 0. 0 times anything is 0. 0 times anything is 0. 0. Always a 0. 0 again. 1 times 1 is 1. Remember that this is a positive J component. 1 times the negative 6 is negative 6, but remember that's a negative I component. And then, of course, always 0. So my answer should be what? 2 negatives make a positive 6, a 1, and then a 0. There's no K's up here, and you're done. All right, next one. So 124019. They give me two vectors, 2, 8, 1, cross, negative 1, 1, 0. Make that a little bit better there. And they want to find the unit vectors whenever you cross them. Unit vectors. And they actually have two of them where I is smaller or bigger, because you could take this cross product and you cross it the other way, like A cross B, and then you can also do B cross A. They're not the same, but they're basically the same kind of numbers. You're just going to get a change of sign, I guess you can say. So they're wanting like the two different whatevers these are going to be. Let me just show you what to do. So cross product, here we go. Always start with a 0. 2 times 1 is 2. That's a K component. 2 times 0 is a 0, so that doesn't matter. Negative 8 with a negative K component. 2 negatives make a positive 8 in the end. 0 in the middle. And then 8 times 0 is going to be a 0 there. 1 times negative 1 right here. It's going to be a negative 1. That's a negative. That's a positive J component, so you'll retain. You'll retain that minus sign. And 1 times 1 is 1, of course, but that's a negative I component, so you'll get a negative in the end. And that's always a 0. Negative 1. My J's, I got a negative 1. My K's, I got a 10. Okay. So what if you were to do, that's A cross B, right? What if you were to do B cross A? What would that answer be? Let me tell you, it's 1, 1, negative 10. You just change your signs. Again, they're not the same, but they're significantly similar. Mainly, though, what we're going to do is we're going to find the magnitude of these guys so that we can do this whole unit vector thing. So magnitude, of course, you know this, is your distance, Pythagorean theorem. Again, you don't need any signs in particular. And you get 102, square root of 102. So this is going to be handy when we start working it. If I had to have a unit vector then, and I'm going to just choose my first one up here. negative 1 over square root 102, negative 1 over square root 102, and then 10 over the square root of 102. Okay, cool. The other one, of course, would be a positive 1. A positive 1. You don't write plus sign in WebAssign, obviously. I'm just doing it for emphasis. And there's your answer. So this is technically, they're saying you have two boxes, you fill it all in kind of thing. But this is your smaller I component, and this is a bigger one. Smaller and bigger is kind of deceiving. It's honestly more negative and more positive. That's how we're supposed to read it. Sorry. So, again, negative means smaller, positive means bigger. That's kind of what they're going with, like on the number line. So then basically these are your two answers. You type them in. You can theoretically take that square root 102 to the front, and so it would essentially look like something like this. And I bet that'll work. That's not what they say. That's not how they give the answer. But I'm pretty sure this will work. You can try it out for yourself. Again, WebAssign's pretty good about the unsimplified stuff. Let's do another one. 124027. So they want the area of a parallelogram. Parallelogram. Close enough. And they give me some points. So point A, negative 3, 0. Point B, negative 1, 5. Point C, 7, 4. Point D, 5, negative 1. Whew. And we're supposed to find out the area. Well, it's not required to do this, but I want to show you through graph how we can at least get something going. So my A point, right there. Actually, you know what? Let me just go ahead and do my tick marks. Was that 5 up there? Yeah. 1, 2, 3, 4, 5, 6, 7. And then 1. I think that's good enough. Okay, so here we go. I got a point here, that's A. I got a point B, is negative 1, 5, right about here. C, 7, 4 is like way over here. Again, not perfect, but close. And then D is going to be 5, negative 1, about right there. And so they're saying that this parallelogram here and here. Okay. I have this drawing tablet that I can't see how I'm drawing. It's like in my lap while I'm looking at the screen here. So it's not really perfect. It's not, yeah, it's just how it is. Moving on. They want this area in here. They're saying how much area do we have in there? And you can probably do some good guesses. I mean, heck, you could probably make some triangles out of this thing and see what the triangles areas would be, and I don't know. I'm not going to go that route. That's geometry, essentially. How am I supposed to do it for this section? Well, we're probably using a cross product somehow. In fact, they want you to create two vectors starting from some point. And I don't know. I choose A. That's easy enough, isn't it? So I'm choosing those two, and what I'm going to do is take this cross product of these guys, and I think all you're doing then is the absolute value of it, or I guess you could say the magnitude of it. So for a formula, I'm going to say the magnitude or the absolute value of the cross product when you're doing this. I mean, there's obviously more text I can use, like starting from one place or something like that. What's going on is that you're going to be using, hold on. Oh, okay, I see. You're going to be using A to B, and then you're going to be using A to D in order to find your vectors. So this guy right here. See how we're going from negative 3 to a negative 1. So how much distance have we covered? We went positive 2 distance. If I'm going from 0 to 5, I've covered a positive 5 distance. Here, we're going to go from A to D down. So negative 3 going all the way to 5. If you note, I'm going from -3 all the way to 5. How much distance? That's 8 distance. I'm going from 0 to -1. How much distance is a -1 distance? Now, I know -1 distance, it makes no sense. Well, again, I'm trying to say, look, it's going down, isn't it? So it's going down. There you go. All right, so we have our two vectors. I'm going to then do the cross product, and we'll get an answer here. So I got this guy cross this guy, and then I find the magnitude absolute value, and we're done. Whoa, hold on. Note the difference. Aren't these 2D vectors? And that formula I gave you was for 3D vectors. So, well, I could just put a 0 in there. Probably. That's fine if you wanted to do it that way. Can I show you the quick way, though? It's much easier. It's multiplying across. So then you got -2, and then minus. There's always a minus sign between them. 5 times 8 is 40. So -42 in the end. This is technically in the K component. I mean, if you want to do like vector stuff and all that. But essentially what's going on is you're cross-multiplying, and you got to put a minus sign between them. But in reality, what you're doing is a determinant, which is going back to matrices and stuff like that. So they're wanting the magnitude or the absolute value or whatever you want of that. So what do you get from that? Again, what they often do is it would be something kind of like this. Notice that the single lines, they've been using single lines for both absolute value and magnitude. I like this. This is good because it's literally the same thing. It's just now here it's 42, obviously. But again, if you have multiple dimensions, you just have to use your Pythagorean theorem instead. So, okay, cool. Well, that was fun. That's the area, by the way. We found the area of this parallelogram. So, in case you're wondering, like, yeah, we got a number. What was it? It's the area. Okay, cool. Moving on. 12,4,033. So they give me 3 different vectors. This one looks like a longer one. -1, 1, 3. Sorry. And then 5, 1, 4. Okay. They want the volume of the parallel pipette. Parallel pipette. I can't spell it. You don't need to know it. It says it on the homework. It'll, as long as you can kind of pronounce it, it's good enough. Parallel pipette. So this is the formula for that volume. It's just a formula is all it is. So we're going to find A, B, and C. You plug them in, you do some math, and then you're done. Honestly, I don't really have to do any more, but I'm going to do it just so that I can get an answer. We're pretty close to the end anyways. So, here we go. Notice that I'm going to do B and C together. I'm sure you could probably mix them up and use whatever vectors you like, but like any kind of order. But I'm just going to stick to the formula here. So, okay. So, let's cross product these guys first. Again, always a 0. I got a -1k component. And then I've got 2 negatives make a +4j component. Keep going. 5, and that's going to be a -k component, so -5k. Always a 0. And then 1 times 4 is 4, and that's a +i component. We got 15, and that's going to be a... That's actually a +j component, so it just keeps its sign. We got 3, but that's a -i component. And, well, good enough. And then there's a 0. So, putting them all together, I got my I components here. Actually make 4 minus 3 is a 1. My J components, you can see that I would get a 19 out of that. Wait. Apparently I don't have 19. Hold on. This 15 right here, did I mess up on it? 3 times 5 is 15, and that's a negative, that's a +j component. Well, okay. I got everything else right, so maybe I was just making... I have a negative sign right here, by the way, in my notes. And somehow it worked out. So, so it's obvious that there's a lot going on. Did I move a 3 or a negative? That's a negative there. Did I not write it correctly? Well, anyways. I have a negative there. Negative J. I don't know why. But I am going to just roll with that. I don't know why. Okay, well, let's go without it. Maybe I got it wrong on the paper and I just didn't realize it. Anyways, even here on the recorded videos, you can see I still mess up even a little bit. Maybe a lot, who knows? So we got 19 there. And then for my K's, I got negative 6. So let's see if I get the same answer. Probably not. We'll see. So I got my A dot and then B cross C. And so what I want to do here is my A vector, which we had before, was 1, 4, 2. And then my cross product, I guess I could just use the vector now, 1, 19, negative 6. And so then when you dot these, you're simply multiplying them, and then you're good to go. So we got 1 times 1 is a 1, plus I got 4 times 19 is a big number, which again I did not prepare for. 4 times 19 is 76. And then we got 2 times the 6 is going to be a 12, but it's negative. So putting that all together, I got the same number. Okay, well, good. We got it right. There you go. I was a little scared. I think maybe I don't know what I did. But it works out in the end. There you go. We got it right. Everyone's happy. Keep going. I only got one more problem left. So yeah, just don't doubt yourself. There's the motto of the story. Don't doubt yourself. That's a positive J component, isn't it? So just retain its sign and you're good to go. Okay, that's the moral of the story. Okay, 12, 4, 0, 39. And so this problem is an application kind of problem. It's a bicycle pedal that's connected to, like, sprockets and stuff like that. There you go. Cool. Close enough. But they're pushing down on this with 60 newtons of force. And with the horizontal, this angle here is 70 degrees. So that angle here is 70 degrees. They also say that this angle here is 10 degrees. If you read the problem, this is 20 centimeters for mine. You might have something else. Immediately convert that. It's a 0.2 meters. So that's what we're going to be using. So they're wanting to know the torque. Oops. Torque is with a Q, not a G. And so the torque is in the units of Newton meters. Newton meters. So there's some point to that. So the only thing we have here is this 70 and 10 between them. Let me give you a formula without using cross product. It's actually very simple. So work or your moment or your torque, there I go again, is always basically force times distance. Now, there's a little bit of difference here because my force is not straight on. It's not perpendicular, which is assumed in this formula. And so what I'm wanting to do is use a sine. So let me show you what this looks like. The final answer, 60 times sine of the 80 degrees. So that's kind of like your force. And then times your 0.2, which is your distance. So force times distance. And I got out of this 11.81769. Again, Newton meters is your units. One thing to note for sure is that your calculator must be in degree mode. Otherwise, well, you'll get the wrong answer. All right. That is the end of 12.4. And I'm glad we didn't mess up anything in the end. Y'all have a great day. Thank you very much.